reactions of amines, which we only have two, okay? Only have two reactions. And what you must remember is how greedy the nitrogen is for carbons and hydrogens. We saw how here he was throwing away the X. Sorry for that. He was throwing away the X here. Throwing away the X, okay? And then the X would come back, of course, because when he's that greedy, he will become positive. And he's going to do the same thing here, because here, let's do the reaction of it with water. So first of all, with water, okay? Reaction of amines, the first one which we do is with water. Let's do the reactions of amines and water, okay? So what do you have? Here you're going to have your amine, whatever type of amine it is, we are not concerned. This is a primary one. Because it's only connected to one hydrogen. And if it meets water, this is going, okay, what you must know is that the reactions of amines are reversible reactions, okay? These are going to be reversible reactions. Now, what happens is, we know how much he likes hydrogen. So it's going to take hydrogen from water, okay? Because it has H plus and OH minus. It's going to split that. And you're going to have it now become an RNH3. There's an NH. So N is still bonded to the carbon and 3 hydrogens. Wow, that's too much for you, my friend. You're going to end up being positive, the nitrogen. But now the OH minus will then be there outside. And here, this will call it an alkyl. We'll call this an alkyl ammonium ion, okay? Because it's an ion. Alkyl ammonium ion. You say to me, what? Isn't the OH minus going to be attracted to him because it's positive? Well, you leave it like that for some reason, okay? Now, the second reaction is going to be the reaction between this and HCl. Okay, so it is the reaction with HCl. The reaction with HCl. Now what happens? You still have an amine, whatever the primary amine, let's put it, and it's going to meet HCl and it's going to be a reversible reaction again. Okay, it's going to be a reversible reaction, okay? Remember, it doesn't have to be a primary amine. So what happens here? Okay, it's a primary amine. It's a primary amine. It has to be a primary amine. So remember, it must be a primary amine. I should actually just put it. It's a primary amine. I just thought. This is a primary amine. It is a primary amine. It should be a primary amine because a primary amine behaves as a weak base. So that is why it's doing these relationships, okay? It behaves as a base. So what happens is, oh, it's greedy for H. Oh, it's so greedy for it. So it's going to be, that is why we saw how greedy it was for carbon. It's greedy for H again. So it's now going to be RNH3. But once you do that, my friend, this is going to be an N+. Then whatever. This chlorine, we know it comes and hunts you down because it's an X, right? It's a type of an X. Like here we had the X's. These are just chlorine, bromine, iron, whatever. So here we, particularly chlorine and bromine, it's going to come and stick itself. And here you now have an alkyl ammonium salt, not an iron, but a salt now, because this is going to be now stable because this minus and the plus are attracting each other. So we can say alkyl ammonium salt. And you are done. There's going to be it, and that's everything. So you're done with amines. Now, what are we left with? Aldehydes and ketones. And we are done. Well done. You've done so much.